Hello students, I hope you're all doing fine at home. Welcome to another lecture of physics. This is my fourth lecture and I hope you understood the previous three lectures of mine. My name is Vibin Abram. Let's get started. Okay, so today we will talk about graphical presentation of motion. Alright, so before I get into it, this is your first class. Let's start this class with a word of prayer. I request all of you to pray with me. Alright. Our Lord Heavenly Father, thank you for giving us this beautiful day, Lord Father. Lord Father, we are going to study, Lord Father. Help us to understand our topic well so that we can use it for the betterment of society, Lord Father. Thank you for listening our prayer. In God's precious name we pray. Amen. Alright. So in the previous in the first lecture that I released, that was based on what is physics. We talked about in totality that what physics means, how to go about doing physics, right? All right. The second two lectures, the afterward two lectures, that is the motion lecture number one, motion lecture number two. In those lectures, we talked about what is distance, what is displacement, what is speed, what is velocity, what is acceleration, what is scalar quantity, what is vector quantity, all these things we discussed, right? I hope you understood all of them. So in totality, we can say that motion is something that we do, right? That means we are changing our position with respect to time, right? All right. So today's topic, that the graphical representation of motion. Now, in today's topic, we have to represent the motion of a body in graphical form, right? So the first question that comes is, what is graph? Like, is it the same graph that we study in our maths book, or is it something else? Yes, it is the same thing. Graph means a graphical representation, right? And we have studied this in our maths subject. I hope you all know a basic idea of what graph is, right? So I'll just, in order to, before starting my lecture, I just want to give you a brief idea about what graph is. All right, graph will be basically a representation, 2D representation of any two coordinates, right? Okay, you have your x coordinate, you have your y coordinate. Now here you can see for every x coordinate there will be a y coordinate. As you can see, I have x values, I have corresponding y values. For 0 x I have 0 y. For 1 x I have 2. For 2 I have 4, 3, 6, 4, 8, 5, 10, 6, and likewise you can see for every x coordinate there is a y coordinate. So basically when I plot this in the form of graph, this is this is something which it will look like. All right. So in the x there are two axes, x axis and the y axis. X axis is the horizontal line, right? Y axis is the vertical one. You can see both are scaled, both the axes are scaled according to data that we have in your left side, yes or no, right? So for, see, all these points, the blue points, the blue dots that you can see, and based on that blue dots, when we meet all the blue dots, we get a straight line, right? So all these blue dot points, they are coordinates, right? So first coordinate is 0 0, that means your value of x is 0, your value of y is 0. Second coordinate is 1 and 2, the value of x is 1, the value of x is 2, the value of x is 1, the value of y is 2. So you can see, you can actually see 1, yes, 1, and then on the y-axis it is corresponding to the point 2, right? The third coordinate is 2 4, that is 2 on the x, 4 on the y. You can, corresponding, you can check whether the coordinates are right or not, right? All right, fourth coordinate is 3 comma 6, that means 3 on the x, 6 on the y. All right, 4 comma 8, 4 on the x, 8 on the y. 5 comma 10, 5 on the x, 10 on the y. And finally 6 comma 10, 6 on the x, 12 on the y. I hope this is clear. This is how you represent a graph, right? Similarly, the same principles that we're going to apply in order when we are describing the motion. But instead of x and y, we will put other values. Okay, let's go back to that graphical representation of motion. Right. So one of the famous graph which represent motion is your distance time graph. Right. We'll talk about velocity time graph also. It's also represent the motion. But here first, the first topic that is distance time graph. Now, what is distance time graph? The change in the position of an object with respect to time can be represented by distance time graph. That means, if, for example, any you know any object you can take, right? Let's say, let's talk about Ramu. Yeah, Ramu is one of the good examples. All right. So if Ramu is moving in a straight line, right? So obviously he will take some time from, let's say he walked a distance of 12 meter, right? So obviously he will take some time to walk there 12 meter, yes or no, right? So when he started at zero time and then he traveled a distance of 12 meter, right? It would have taken some time. So he's changing in his position from 0 to whatever time it took him to reach the 12-meter mark, right? So he's changing his position from with respect to time, and that we can represent in a form of a graph. That is what we call as your distance time graph. All right, so I have an example here. Let's take the example of Ramu only. Ramu is my favorite example. Okay, so you can see here, so we have Ramu. For now I have, instead of x and y, I have time and distance, right? So the topic is distance time graph, right? So we'll talk about distance and time, how the how as the time is increasing, how the distance are changing, right? So that's why the distance time graph. All right, so when the time is 0, the distance traveled by Ramu is 0. All right, when the time is 10 minute, the distance traveled by Ramu is 20 kilometer. All right, he's very fast. I don't know, he's riding a bike or something. No idea. Okay, when the time is 20 minute, the distance is 40 kilometer. All right, great. When the time is 30 minute, the distance is 60 kilometer. Okay, when the time is 40 minute, the distance is 80 kilometer. And when the time is 50 minute, distance he has traveled is 100 kilometer. And similarly, when it is 60, that means 1 hour, he will travel a distance of 120 kilometer. All right, so you can see. Achha, the next question that I will ask, is it uniform motion? Tell me, think about it. Is it uniform motion? Yes, it is uniform motion. You can see, as the equal interval of time, that is 10 minute separation is there, as the equal interval time is changing, the distance is also changing equally, right? So every 10 minute, Ramu is traveling a distance of 20 kilometer. You can check it. For every change in 10 minutes, he is traveling a distance of 20 kilometer, right? So this is an example of uniform motion, right? So when we plot it on the graph, it will be something like this. You can see, instead of my x-axis, I have time on my x-axis, time in minute, and instead of my y-axis, I have distance on my y-axis, distance in kilometer, right? So the first coordinate, that is 0 0, that is 0. For 0 minute he has traveled 0 kilometer, right? Okay, second one, for 10 minute he has traveled 20 kilometer. For 20 minute he has traveled 40 kilometer. For 30 minutes he would have traveled 60 kilometer. In 40 minutes he would have traveled 80 kilometers. In 50 minutes he has traveled, actually no, not he would have, he has traveled 100 kilometer according to our table. In 60 minutes he has traveled 120 kilometers. So you can see, for uniform motion you get a straight graph. You see, you are getting a straight constant line without any breaking. This kind of graph is whenever we plot a distance versus time graph. This is also called distance versus time graph or distance time graph. This, what actually we are doing, we are actually plotting the motion of Ramu in the form of graph. So in the graph, from looking at the graph, you can see that Ramu is traveling in a straight line and is traveling with a uniform speed. I hope this is clear. Now, in the question, you can see it's nowhere given what is the speed of Ramu, right? So, yeah, so it is the example of uniform motion. All right, so nowhere it is written that what is the speed of Ram. We just know the information that at this time he would have reached this point. At this time, we would have reached that point. All right. So in this particular one of the good point about this distance time graph is that we can find out the speed of Ramu with the help of this graph. Now you might be asking like, how sir, how can I find the speed with the help of this graph? How is that possible? All right. How is that possible? You have to find out the slope of the graph. Okay, now what is slope? Okay, let me explain it to you. Don't go technically. Slope, you know what slope means? Slope means if you have a slope, you will slide with the slope. Yes or no? So you can see this graph, this straight line is considered to be at some slope. Yes or no? It is at some slope. If I put an object, that will slide down to 0. If I put an object at 10, it will slide down to 0. Yes or no? So it has some slope, it has some angle with the time axis. Yes or no? Right? So that's what slope is. Now don't go to the technical term, technicality. You just focus that how can I find out the slope. In order to find out the slope of the graph, what you have to do, you have to see first, the first thing is that you can only find out the slope of a uniform motion. Whenever you have a uniform motion, or the time period till you have uniform motion, you can find out the slope. All right, the first thing is that. Second thing, that you have to, in order to find the slope, you have to put 2 points on the line in such a way that those 2 points should not be your, you know your coordinate point. Apart from coordinate point, select any 2 point on the line. First do that. Okay, let me select it. Okay, that is my first point, that is my second point. So I have selected the point. Now all you have to do is you have to find out the coordinates of that point, right? So how will you find out the coordinates? You will make parallel lines, right? Parallel lines which is parallel to your time axis, which is intersecting on your distance, your y-axis, your distance axis, right? Then you again made a parallel line, then perpendicular line which is actually touching your time axis again. So basically based on that, you will find out the coordinates, and you can see a triangle formation, ABC. A triangle is formed, right? Then you will find out the coordinate. You can see that point is 90, right? Because it is in between 80 and 100. That point is 90, that point is 50, that point is 25, that point is 45. So if somebody asks you what is the coordinate of point A, what will be it? The coordinate of point A will be, yes, 25 comma 50. Agreed? Yes or no? 25 comma 50, that means 25 on the x and 50 on the y, right? Similarly, if somebody asks what's the coordinate of point B, what will be it? The coordinate of point B, yes, it will be 45 comma 90. Yes or no? 45 comma 90. I hope this is clear. I hope you're getting it. Okay, if somebody asks you what's the coordinate of point C, what will you say? The coordinate of point C, yes, it will be 45 comma 50. I hope you're getting it, right? So basically we have find out the coordinate, right? So you tell me, if you are supposed to find out the speed, how will you find out? Speed is something which is, see, basically you see this S2 minus S1 that I have written. What is this S2 minus S1? S2 minus S1, S2 means the final distance. That means the distance that it has traveled accordingly. S2 means the y coordinate of point B, or I should say the distance coordinate of point B. Similarly, for C, S1 means the distance coordinate of point C. I hope you're getting it. See, point B means the distance coordinate of point B, that is 90. In the case of B, it is 90. S2 means 90. S1 means it is 50. Similarly, T1 minus T2. T1 means your time. T2 means the 45, the coordinate, the time coordinate of point C, and T1 means the time coordinates of point A. Here the T2 is 45 minutes, T1 is 25 minutes, right? So basically we have to find out that from A to B, if Ramu has to travel from A to B, at what speed he will travel. So basically, in order for Ramu to travel from A to B, he has to travel a distance of S2 minus S1. Yes or no? Think about it. In order for Ramu to travel from A to B along that particular direction, he has to travel a distance of S2 minus S1. Yes or no? In T2 minus T1 time. I hope I'm making myself clear. अगर रामू को ए से बी तक जाना है, राइट, ए से बी तक का जो डिस्टेंस है दैट अगर उसको ट्रैवल करना है तो उसको S2 minus S1 मतलब बी पॉइंट का कोऑर्डिनेट क्या है आपका 90, सी पॉइंट का कोऑर्डिनेट क्या है आपका 50, राइट. वी आर टॉकिंग अबाउट कि हाउ मच डिस्टेंस दैट ही विल ट्रैवल इन हाउ मच टाइम, राइट. सो BC is the distance that he has to travel and AC is the time in which he will travel, right? So speed is simply given as distance upon time. Yes or no? Right. So distance that he has to travel is S2 minus S1 in what time? T2 minus T1 time. Now all you have to do is put the values. Value क्या है आपका? See, आपका S2 क्या है? That is S2 means the distance coordinate of your B point. Yes or no? And that is 90. S1 क्या है? The distance coordinate of your C point, that is 50. What is T2? The time coordinate of point C, that is 45. What is T1? The time coordinate of point A, that is 25. So we have put the value, and when we calculate this, we will find V is equals to 40 upon 20, and the velocity is coming out to be velocity or speed is coming out to be 2 kilometer per minute. That is the speed of this particular, Ramu is traveling with 2 kilometer per minute speed. I hope this is clear. Ramu is traveling with 2 kilometer per minute. Now this calculation that we did, this is how we find out the slope of a curve, slope of a graph, right? This whole process is how you find out the slope of the graph. So whenever we find out the slope of a distance time graph, we will always get the speed of the motion traveled by the object. I hope this is clear. Whenever we find out the slope of a distance time graph, we will always get the speed of the object that has traveled that particular motion. I hope this is clear. Right. Okay. So if that is clear, let's move to our next part, that is distance time graph of a car moving with non-uniform speed. Now till now we were discussing about uniform motion. Now what will happen if my car is moving in a traffical area? What will happen? Let's take a look at this. Let's say now this time Ramu is traveling in a very traffic full area, right? Okay. So now the time is in second, distance is in meter, right? So Ramu this time is, I think he is walking. All right. So for zero, when the time is 0, he has traveled distance of 0 meter. When the time is 2 second, he has traveled distance of 1 meter, very slow. When the time is 4 second, he has traveled a distance of 4 meter. All right, great. When the time is 6 second, he has traveled distance of 9 meter. Very variation is there. When the time is 8 second, he has traveled distance of 16 meter. Okay. When the time is 10 second, he has traveled distance of 25 meter. When the time is 12, he has traveled distance of 36. So you can see a very unequal kind of variation is there. These kind of variations will always lead to non-uniform motions, right, or non-uniform speeds, right? So when we plot this graph, we get a graph something like this, a curvy graph, not a good graph, not a straight graph, but a curvy graph. So whenever we have uniform motion, we'll get a straight curve. Whenever we have non-uniform motion, we'll get a graph, a curvy graph like this. I hope this is clear. Am I clear? I hope this is clear. The next type of graph is velocity time graph. It is same thing. The only difference of velocity time graph with your distance time graph is that instead of distance axis you will be having velocity axis. Instead of say in distance time graph you have time on your x-axis and you have distance on your y-axis. So in velocity time graph we'll be having time as usual on the x-axis, and instead of distance we'll be having velocity on the y-axis. So what it actually does, the change in velocity of an object moving in a straight line with respect to time can be represented by velocity time graph. So how much the velocity is changing with respect to time of any body which is traveling, that is represented by your velocity time graph. So I have an example of velocity time graph here. So you can see here you have your y-axis velocity which is in kilometer per hour and your time is in r in your x-axis. So you see when the time is 0 hour, the velocity is 40 kilometer per hour. When the time is 1 hour, again the velocity is 40 kilometer per hour. When the time is 2 hour, the velocity is again 40 kilometer per hour. 3 also, 4 also, 5 also, similarly 5 also. So the time is passing by, the velocity is remain, velocity is constant. That means there is no acceleration happening. That means the person who is driving the car or whatever it is, he is not, he is at constant velocity, he is at constant speed, there is no acceleration happening. All right, now one of the good thing about this particular graph is that the area under velocity time graph will always gives us the distance traveled by the body, right? So just like in our previous case, all you have to do is choose any 2 points apart from the coordinate points on the line. For example, let me choose this point and let me choose these 2 points. So between these 2 points, how much the how much distance has been traveled we can find out. How will we find out? Same thing, we have to draw the lines, right? So draw the lines, find out the coordinate. You have point A, point B, point C, point D. What will be the coordinate? So area under this particular graph, right? Area under this particular graph will tell me that what is the distance traveled by the body from A to B, right? So the coordinate of C point is 1.5. Why? Because it is between 1 and 2. The coordinate of point D is 3.5. Why? Because it is between 3 and 4. Right. So how will you find out the area of the shaded region? See, you can see this A, B, C, D is actually a rectangle. Yes or no? And what is the area of rectangle? Yes, area of rectangle is, yeah, length into breadth. Yes or no? That means AB into AC or CD into DB. Same thing. Yes or no? That's how you will find out. Yes or no? So area under the graph always gives us distance here, right? That is the important thing about velocity time graph. In distance time graph, the slope will give us the speed of the motion of the body. In velocity time graph, the area under the graph will give us the distance traveled under that particular interval. Yes or no? So distance moved by the car in time t2 minus t1. So there is the time the coordinate. You can see the coordinate. T2 is your 3.5 hour and t1 is your 1.5 hour. So the distance that has been traveled between 3.5 hour to 1.5 hour, that we can find out by the area under the particular shaded region. Yes or no? Right. So how will you find out? You have to find out the area. Area is AC divided multiplied by CD, or you can also write BD multiplied by CD. एक ही बात है, same thing will happen, right? So your value of AC is actually height. What is the height? 40 kilometer per hour is the height. Yes or no? See, what quantity is there, we have to find out. The quantity is velocity and that is in kilometer per hour. So we will write the value of AC is 40 kilometer per hour and the value of CD is nothing but T2 minus T1. Alright, that is 3.5 minus 1.5 R. Alright, so it is 40 kilometer per hour multiplied by 2 R, right? R will cancel out. The area will come out to be 80 kilometer. So hence the distance traveled between 3.5 to 1.5 r is the area under the curve, that is 80 kilometer. 80 kilometer distance must have been traveled between those 2 points A and B. I hope this is clear. This is the important thing about velocity time graph, right? So this is how you will find out the area under the graph, right? Okay, let's take uh, now what will happen if the car is moving with uniform acceleration. Now in the first case जो अभी जो हमने case किया, there was no acceleration, yes or no? Can you, like, did you see any acceleration? No, there was no acceleration at all. So there was no acceleration at all right? So this particular example, we will be having a uniform acceleration. Uniform acceleration means the speed will be changing uniformly. All right, so you have this time velocity table, right? So here you can see when the time is 0 second, the kilometer per hour, the velocity is 0. When the time is 5 second, the velocity is changed to 10. When the time is 10 second, velocity is changed to 20, 15, 30, 20, 40, 25, 50, 30, 60, and so on. You can see it here, right? Okay, so you can say the time is getting changed, right? 5, 10, 10, 20, 15, 30, 20, 40, 25. So you can see equal interval of time has been passed, equal interval velocity has been changed. So it is a uniform acceleration. The acceleration is uniform. This is very much confirmed. So when we draw a graph of uniform acceleration, this is, you will get a straight line. So as I said in my first example, whenever there is something uniform, we will always get a straight line, right? So this is the proof. You will always get a straight line when you have uniform motion, uniform acceleration, uniform speed, whatever it is, right? So in this particular case, you have uniform acceleration, the speed is increasing uniformly, right? So you'll get a straight line. Okay, same graph, like I said, area under this graph will also tell me distance traveled by the object. So how will you find out the area under this graph? The first thing is that you have to choose any 2 points which is not the coordinate point, right? So I have chosen any 2 point, right? Then you will find out the coordinates by drawing parallel lines, right? So I have drawn the parallel lines. So you can see I have A, D, E, B and C. So what is the area here? See, I have 2 points, point D and point A. So point D correspond to some B coordinate time, point A correspond to C coordinate time, right? So I have to find out the distance, traveled in between this B and C time. Alright, so how will I find out? Like I said, दोनों point के बीच में area, right? So currently I can see point A and D is taking an area of A, D, B, C, E and back to A. There is a triangle and then there is a rectangle. Can you guys see that? There is a triangle is A, D, E and then there is D, B, C, E, D, right? So there are two figures here, a triangle and a rectangle. So that combined will give me the area under the graph. Yes or no? You have two areas, that is area of triangle plus the area of rectangle, right? ADE is the triangle, then DBCED is the rectangle. So area under the curve is equals to area of triangle ADE and area of rectangle DECB. I hope this is clear. So basically, you know what is the area of triangle? Area of triangle is half base into height, right? So area of triangle ADE is equals to half base is your DE and height is your AE. I hope these formulas you have learned in your maths class, right? Plus area of rectangle DBCE क्या है? DB length into breadth, DB multiplied by PC or BC multiplied by C. Yes or no? So just simply you have to find out the coordinates this time, right? Area of triangle AD, that is area of triangle AD is equals to half into base. D is same as your base is BC. Yes or no? So all you have to do is find out the coordinate of B and C, right? So C is in between 20 and 25, right? 20 and 25 in between is 22.5, and B is in between 10 and 15. Between 10 and 15, that is coordinate is 12.5, right? So you can see half into 22.5 minus 12.5, that will give me BC, or simply will say DE, yes or no, right? Multiplied by the height is AE, right? Now AE will be, yes, A will be the velocity component, right? Okay, so the coordinate of A over the velocity part is, it is between 40 and 50. That will be, yes, that will be 45, correct. The E part is in between 20 and 30, that is 25. So 45 minus 25 will be my AE, right? So that is, when we calculate it, it come out to be 100 kilometer. All right, so for the area of triangle ADE is 100 kilometer, right? Now the area of rectangle, the next part, that is rectangle DEC and B. All right, so that is length into breadth. What is the length? Length is your dB. Now dB is equals to, you can see the coordinate of B is 0, the coordinate of D along the velocity is, it is between 20 and 30, that is 25. 25 minus 0, that is 25, multiplied by BC. BC we have already find out, that is your 10, right? BC is 45 minus 25, that is 10. When we calculate it, it come out to be 250 kilometer. The total distance that have traveled inside point A and point D is the area of triangle plus the area of rectangle, that is 100 plus 250, that is 350 kilometer. So that means from point A to D we would have traveled 350 kilometer. I hope this is clear. So in totality we can say the area under the graph will always give us distance for velocity time graph. I hope this is clear. For distance time graph, the slope will give me the velocity. For velocity time graph, the area under the graph will give me how much distance I have traveled from any two particular point. I hope this is clear. All right, so velocity time graph in the case of non-uniform acceleration. Whenever you are having non-uniform acceleration, right, that means you're accelerating unequally, right? So what will happen? You'll get a graph like this, right? So the velocity is, you can see in the first graph, you can see as the time is passing by, the velocity is decreasing, right? It is decreasing. In the second graph you can see it is increasing, then decreasing, then increasing, then decreasing. So these are the examples of, non-uniform accelerated motion, right? So you can see the graph is not a straight line, it is curvy lines, right? So when you had uniform acceleration, the graph was a straight line, but when you have non-uniform acceleration, the graph was curvy line. I hope this is clear. Okay, that's all for today. Now the questions for homework, these are the questions for homework. So what can you say about the motion of an object whose distance time graph is a straight line parallel to time axis? Okay, what it is, you have to tell us. What can you say about the motion of an object whose velocity time graph is a straight line parallel to the time axis? Okay, tell. What is the quantity which is measured by area occupied below the velocity time graph? You can tell that. Ramu is traveling towards the school from his home. The distance covered by Ramu at different time is shown in the table. You have a table. Plot the distance time for it. Okay, you have to plot distance time. You have to given the time and the distance of the table. Okay, so these are the questions that you have to do it in your copy. I hope you understood the lecture. If you did understand the lecture, do give me a thumbs up by stating that you understood the lecture. All right. Okay. So I hope you understood it. Thank you so much for watching.